Final talk today. Very pleased to introduce Anthony DeCicco from Northrop Grumman, and he will talk about advanced electronics for space systems of the future.
Thank you very much for that introduction. I'd like to just give a little introduction here. I work in the space systems sector over at Northrop Grumman. You might know my colleague here, Andy Quas, who is really the leader at our company when it comes to additive manufacturing. And he's asked me to talk today a little bit more on the details of how spaceflight, and especially the considerations for spacecraft electronics, are evolving, and how we may actually be able to use flexible hybrid electronics or electronic printing in order to be able to address those issues. So in my role in the company, I really focus on how we take technologies and processes and actually bring those into performance, cost, and schedule for new products that we want to essentially have for the government to be able to use, and then also for commercial ventures as well. So what does Northrop Grumman actually do in additive manufacturing? Well, we actually do quite a lot. We've already inserted metal products, polymer products, also looking at composite products as well, into spacecraft that are flying right now. And then also we're inserting this into spacecraft that are coming out in the future. We've done this both in the space arena, and we've also done this in the aircraft arena as well. And the next step for us is we're bringing electronic products also into that consideration for when we look at what are spacecraft going to look like in the future. So within Northrop, we have over 400 employees that at any given time are working on manufacturing. They're working on these insertion of the programs and doing real research on how we develop these processes in additive manufacturing. And from that investment that we've really had within this company, we have our own conference. We have weekly calls where we help solve each other's problems. And we really see that this insertion has already been successful, and it's helped us a lot in those three aforementioned areas I talked about before. But also customers are really seeing that this is where manufacturing needs to go as we think about how advanced manufacturing as an ecosystem addresses the needs for spacecraft. So I'd like to bring up a little bit about where can print electronics take us when it comes to what I would say are the low-hanging fruit. So some of you may not work in spacecraft and may not work in how we actually build spacecraft, but the harnesses of today is really what you see right there. The very customized sets of hardware that takes a lot of technician hours in order to be able to develop. And so when we look at, for instance, I'll bring up Starlink, they've been able to achieve something that I think is actually quite ingenious. They have a spacecraft platform that performs one function. They're able to produce dozens of these at a time, and then, of course, launch dozens at a time into orbit as well. But the rest of the spacecraft arena really hasn't operated like that at all. So when we look at what we call proliferated LEO or maybe proliferated GEO, and that's where I really see the usage case here when it comes to spacecraft harnesses, we're not there yet. So what we'd like to get to is a point where we take the harnesses from right over there, and this is actually the Orion service module, and that's a collaboration there between NASA and ESA. And we want to get over to a point where we have the spacecraft harnesses actually printed within that. What is that going to do? It's going to bring us to serialized production quicker. So even though you may have a spacecraft bus, and there's some commonality between spacecraft bus to spacecraft bus, the customization on the payloads that you have and then what their requirements are is really where the manufacturing essentially cost really comes into the equation. And so if we can find a way to actually do production such that we're not even thinking about third shift and we're reducing what second shift really needs to do for doing these kinds of integrations to a point where we get to, and this is a project from a few years ago that we did UTEP, where we can plug cards into a bus. Well, that's really, I think, the game changer when it comes to how we integrate this into the spacecraft architectures. But then the other part of it is, another thing is thermals in space. And so we do a lot of different types of thermal control in space, but one of them, and I think this is another low-hanging fruit, is heaters. So heaters, we have, I don't even know what the last count was, but well over 100 different sizes of heaters that are used on spacecraft, from spacecraft to spacecraft. And that, of course, has a lot of stock. There's a lot of design considerations on the thermal side for how we actually are going to put these into spacecraft, and it's usually never ideal. And when we get to a point where we're actually able to print these in situ, print them conforming around structures, print them conforming around the electronic box that we want,